For those of you that had a hard time finishing up that IXL code yesterday, because it was a lot of work to solve for a variable to then substitute in, this lesson is for you, okay? This is the third strategy for solving systems of linear equations, and it works really, really well on problems that are set up like the ones that you saw at the end of your IXL code yesterday, okay? So we're gonna do a couple of examples. I'm doing this lesson over 2 days. So we'll start it today with like the foundation of the procedure, and then on Tuesday we'll finish it up, and then you'll be able to do your IXL code. So for today, your homework is just a few problems for you to practice. And like I said, do be sure that you know the lesson before you go in and try to do those problems, okay? All right, first example. So here's your system. 3x plus 3y is equal to negative 21. Negative x minus 3y is equal to 19. Okay, I'm gonna let everyone get that written down so that your eyes can be on the screen for the next part. So go ahead and write that down. Hugo, can you take your earbuds out until after the lesson? Thanks. Did everybody have it? Okay. So elimination works like this. You're basically going to set up a huge addition problem with your two equations. Okay. So let's see what happens when we add those two equations together. 3x minus x is 2x. 3y minus 3y is just 0, so this has a value of a 0. And then negative 21 plus 19 is negative 2. So we call this method elimination because by adding the two equations together, we were able to eliminate our y terms. Okay. And now all I have to do is divide both sides by 2, and we get that x is equal to negative 1. What do you think about that? Okay. I actually was considering, like, I feel like I should have maybe taught this method to you before substitution. And this is the first year I have taught this method at Chilton. I've been here for 5 years, and we've only taught graphing and substitution. And last year I linked some videos for the kids to say, like, hey, there's this third method, check it out if you want. And they loved it. So I figured, okay, we're gonna go ahead and teach it this year and see how you guys like it. And so far the response has been positive after first period, and it seems like you guys too. I think that this method will be good. Now, I mean, we still have some legwork to do here. So we were able to eliminate our y terms, and we were able to solve for x. Now we need to plug x in to one of those two equations and solve for our y. So I'm just going to use that first one. This will be 3 times negative 1 plus 3y is equal to negative 21. And I'm just going to go through and solve for y. You guys know how to do that already. Okay. All right, so our ordered pair is going to be negative 1, negative 6. Now I do want to make sure that I've done this correctly, so I am going to take a moment just to check my answer I used the top equation to find x, so I'll use the bottom equation to check my answer. So this will be negative 1 minus 3 times negative 6 equals 19. So this is 1 plus 18 equals 19. So yeah, I could see that that's going to work, and my answer is correct. Yes, Jordan?
You wrote the y as x.
Did I?
Yeah.
Oh, yeah, you're right. Good thing I have my white out. You know what's funny is during first period, I constantly make errors, and I don't think the kids either. They don't see it or they don't want to call me out on it. But like, I'll look at the notes and I'm like, oh my gosh, I misspelled this and nobody said anything. Or I wrote the wrong word and nobody said anything. Okay, I'm going to have you guys try this now. All right, check that out. You're going to add those two equations together to eliminate one of your variables. This time, yeah, but on the next one, I'll let you slip in them. All right, you guys. Did you guys get a y value yet?
Yes.
Okay, if you got a y value, what'd you get?
I got 3.
3? Okay, let's check it out. We're adding these two equations. Negative x plus positive x has a value of 0. And then 10y plus 6y is 16y. 24 plus 24 is 48. Yeah, I would agree. I would say my y is 3. And then I'm going to plug that into one of the equations to figure out what my x is. Did you guys get that x is 6?
Yeah.
Wonderful. Okay. So our ordered pair then is 6, 3. Okay, Let's take a look at a different type of problem now. So these ones were nicely set up. You just had to add the two equations and you were able to eliminate one of the variables. Well, sometimes it's not always super nicely set up. I do have an example. I mean, it's not that far of a leap for what we've done so far, but you are going to have to think about it a little bit more. So let's say that we have these two equations. Okay, with this one, both of the 5x's are positive. So there are two strategies that you can use here. One strategy is just pick one of the equations, multiply the whole thing by -1. So if I do that for the first equation, this would be -5x minus y equals positive 24. And when you do that, then you can add your two equations. The 5x's will cross themselves out, and you can move on. Another strategy is to subtract the whole second equation. So if I subtract this, then it would be 5x minus 5x, y minus 10y, and -24 minus 30. Okay? So what I'm going to do, because I feel like half of you tend to like one method and half of you tend to like the other, is I'll work it using both methods. Okay, so I'll do it twice. Okay, so for this first set of equations right here, I'm going to multiply that first equation by -1, which is going to make all the signs switch here. So this is going to be -5x. This is going to be -y and a positive 24. Now I can go through and add the equations like I did above. So -5x plus 5x, you eliminate that. It has a value of 0. -y plus 10y is a positive 9y. Positive 24 plus 30 is going to be a positive 54. Divide both sides by 9, and I get that y is equal to 6. Okay. So that is one way of doing it. You just multiply one of the equations by a negative number, a -1. It switches the signs, and then it's nicely set up to add. Or if you would like to subtract your equations, you're subtracting the whole thing. So 5x minus 5x, that has a value of 0. Y minus 10y will be -9y. And -24 minus 30 is going to be -54. Then if I divide both sides by -9, you get y is equal to 6. Either way you approach it, you're getting the same answer. How do you feel about that? Good? Do you each have a method you feel like you'd prefer? Okay, awesome. Okay, try your method now. I'm not going to go through the whole thing of plugging y back in to find x. You guys are good with that. So I'm going to have you just practice now. So 4x plus 6y is equal to -24. 4x plus y is equal to 26. So choose one of the methods from above and see if you can figure out one of the values of the variables. You don't need to solve it all the way out unless you would like to. Just find the value of one variable. you guys get for y? Negative 10?
Yeah.
Everybody got that? That's a good sign. Okay, I'm gonna subtract these. So 4x minus 4x is 0. 6y minus y is 5y. Negative 24 minus 26 is negative 50. Yeah, I would agree. Y is equal to negative 10. All right, you guys, you have about 15 minutes. Go ahead and do that homework so that way you don't have anything to work on over the weekend, all right? I forgot yesterday's notes. I'm not sure.
I haven't written anything.
But I'm gonna, I don't have